Welcome everyone to this presentation on a topic of chemical engineering thermodynamics. The presentation has been prepared by me, Yash Goel, and my friend Zansrukia Parth. We would like to thank our faculty guide Krunal Suthar sir for his constant support. The topics that we'll be covering in this presentation are the compressibility factor, reduced properties, principle of corresponding states, generalized compressibility charts. The compressibility factor Z is also known as the compression factor or the gas deviation factor. It is basically a correction factor which describes the deviation of a real gas from ideal gas behavior. It is simply defined as the ratio of the molar volume of a gas to the molar volume of an ideal gas at the same temperature and pressure. Z is equals to PV by RT. It is a useful thermodynamic property for modifying the ideal gas law to account for the real gas behavior. Compressibility factor values are usually obtained by calculation from equations of state such as the virial equation. Reduced properties. We have three reduced properties: reduced pressure, reduced temperature, and reduced volume. The reduced pressure of a fluid is defined as its actual pressure P divided by its critical pressure Pc. The reduced temperature of a fluid is its actual temperature divided by its critical temperature. Similarly, the reduced volume is the actual volume of the fluid divided by its critical volume. Principle of corresponding states. This principle indicates that all fluids, when compared at the same reduced temperature and reduced pressure, have approximately the same compressibility factor and all deviate from the ideal gas behavior to about the same degree. Mathematically, the principle means that the compressibility factor Z is a function of the reduced temperature and pressure. The principle is only an approximation. It works best for gases composed of spherical molecules. The principle fails for non-spherical molecules. Its significance is that it enables to coordinate the properties of a range of gases to a single diagram such as the generalized compressibility chart. Generalized compressibility charts. Alternatively, the compressibility factor Z for specific gases can be read from generalized compressibility charts that plot Z as a function of pressure at constant temperature. On these charts, Z is plotted as a function of reduced temperature and reduced pressure. It provides one of the best means of expressing deviation from ideal behavior. When the precise equation of state is not available, these charts provide a convenient method for evaluating the compressibility factor. That's all for today. Thank you. Please like, share, and subscribe.